This is Where We Live on Connecticut Public Radio. I'm Lucy Nalpathanchel, broadcasting remotely. Lions and rhinos and bears, not at the local zoo. I'm talking about well-preserved ancient animals, their carcasses uncovered in Siberia in permafrost, the permanently frozen land in the Arctic that's now thawing in areas. Today, Where We Live, we hear from scientists about these amazing discoveries. The latest was an Ice Age bear found by reindeer herders in Russia last month. But permafrost thawing has major consequences for our planet, and we can't forget about the people who live in the Arctic and whose homes and livelihoods have also been affected. Joining me now on Zoom is Dr. Sue Natali. She's Arctic Program Director and a scientist at the WOODWELL Climate Research Center, formerly known as the Woods Hole Research Center in Massachusetts. Sue, welcome to our show.
Thank you. Good morning, Lucy.
And you can also join our conversation, 888-720-9677, or find us on Facebook and Twitter at Where We Live. Now, Sue, I understand you're an Arctic ecologist, so you're doing research in both Alaska and Siberia. I was talking with my producer, Carmen, about how we would both love to go to the Arctic one day. Many people will never visit, but can you describe this place for us and what it looks like and feels like?
Yeah, sure. I could probably talk about that for several hours because one thing, we tend to think about the Arctic as a place. We think about tundra and a treeless place, and it's actually really diverse. I mean, some parts of the Arctic are very rocky with very little vegetation, and some areas are tundra without trees and low growing vegetation. Very spongy ground because there's a lot of mosses that grow there. And then there are other places in the Arctic, particularly large areas of the Russian Arctic, that are covered in trees. One of the sort of features that kind of crosses all of these different types of ecosystems is the permafrost.
So tell us more about permafrost. What is it exactly?
Yeah, so permafrost is perennially frozen ground. So the official definition of permafrost is it's ground that remains below 0 Celsius or 32 Fahrenheit for 2 or more consecutive years. That ground can contain any material. So it's defined by the thermal conditions. So it can contain soil or ice or rock or sediment or dead animal carcasses. All of these are components of the permafrost layer.
And so if we were to visit, say, parts of Alaska or even Siberia, for a casual viewer, you may not be able to see permafrost unless you're drilling down. And so how far deep does it go?
So the top of the permafrost layer can be very close to the ground surface. In some cases, just a foot down. So you could pretty easily, dig a hole and reach your hand down and touch this frozen ground. The thickness of the permafrost itself really varies depending on where you are in the Arctic. So it can be anywhere in warmer places of the Arctic or the subarctic. It can be, a few feet in thickness to up to, a half mile deep. So it can be, the Arctic is a really large place, and the permafrost region is really diverse and covers sort of a lot of area with quite a bit of a temperature range. So we have a lot of variability in the depth to permafrost and the thickness of the permafrost itself.
I mentioned earlier that parts of the permafrost are thawing, and that's impacting the people who live in the Arctic. Can you talk more about these indigenous communities, and as we hear about the thawing, how that's impacting where they live?
Yeah, so, I think in some places of the planet who haven't yet been directly feeling the impacts of climate change, I think those places are decreasing. It may be hard to think about the fact that the climate has been changing and people are being impacted and have been for many years in the Arctic. And, one of the things that's, I think, quite unique about climate change in the Arctic is that when the permafrost, it's not just getting warmer, but when the permafrost thaws, the ground can actually collapse. So, if you think about there's ice in the permafrost, and when the ice melts and turns from ice to water, you're losing the ground structure. And so you can imagine what that means if you had a house on top of permafrost and the ground started to sink. There's also a lot of gas and oil infrastructure and roads. And so what this means is that people and communities who are living in areas where the permafrost has already started to thaw is that they're continuously having to jack their houses up to keep them level. People are having to move houses. Whole communities are having to make really, really difficult decisions about moving from places where they've lived for hundreds and thousands of years.
Again, you're hearing Dr. Sue Natale, Arctic Program Director and Scientist at the WOODWELL Climate Research Center, as we learn more about permafrost and the impacts of it thawing in places like Alaska and Siberia. Sue, I wanted you to talk more about, we think about this as frozen land, but as it thaws, what is the material that is in the permafrost that we're not thinking about necessarily beyond ice?
Yeah, so there's a lot of carbon in permafrost, and I think that it's the carbon that's in the permafrost, which is why it makes it so important for everyone on the planet. And when I say a lot of carbon, I mean a lot of carbon. So the current estimate is about 1 to 1.5 trillion tons of carbon that's in permafrost. And that's such a huge number. It's even hard for me to wrap my head around what a trillion means. And so just to give you some context, it's twice as much carbon that's stored in the permafrost region as is in the atmosphere, and 3 times as much carbon stored in permafrost region as in all of the world's forest biomass. So this carbon is currently, for the most part, in a frozen state. It's in the form of organic material. So that's just, if you just think about your organic rich soil or your compost, when that organic material thaws, it then becomes available for microbes who break it down, they use it for energy, and the byproducts of that process are 2 greenhouse gases, carbon dioxide and methane. And it's these emissions of carbon dioxide and methane and the potential for these emissions in the future is why this thawing of the permafrost makes it really relevant to everybody on the planet.
So talk more about that when we think about global warming, how much faster it's happening in the Arctic, Sue.
Yeah, so, the Arctic is warming, more than 2 times faster than the rest of the planet. And this is expected to continue into the future. At the Paris Agreement, the international community set a global sort of temperature threshold of 2 degrees Celsius, and the Arctic has already surpassed that. So as I said, these are changes that are happening now. There's a number of reasons why the Arctic is warming faster. People call this Arctic amplification. I think one of the biggest ones is the fact that we're losing snow and ice in the Arctic, and these very white surfaces that were reflecting the sun's energy are now absorbing it. You're getting these very dark oceans and these very dark ground surfaces that are now absorbing that, causing this regional warming in the Arctic.
So we're talking about parts of the landscape being devastated by floods and the shifting, but there's also fires there. Sue, tell us more about that.
Yeah, this summer was a record year in the Arctic, once again, for a number of reasons. There was this record heat wave of 100 degrees Fahrenheit in Siberia, and then there were also record wildfires this year. And these wildfires that are happening across the Arctic and forested and in tundra regions and areas that have a lot of peat, so very, very carbon-rich soils. These are important for a couple of reasons. First, there's this sort of obvious initial pulse of carbon when you burn down trees. In the Arctic, the fires also burn the soil because there's so much carbon there. But the vegetation in the surface soil acts as a very good insulator for the permafrost. So in the summer, when you're getting these very warm temperatures, even up to 100 degrees Fahrenheit, they insulate the permafrost from these very warm temperatures. And so when you burn them off, it's like lifting the top off of a cooler on a hot summer day. And so now we have this sort of double problem, which is that not only are we having these very warm temperatures, but we're having these very warm temperatures, and we've also removed this sort of ecological cover or ecological insulator, causing the permafrost to, warm twice as fast and thaw twice as fast, and also leading to some very abrupt thawing events where you can get pretty extreme ground collapse.
So, in the sense, when we think about the thawing, it's a consequence of climate change, but also a driver of climate change because of the emissions that you said, the greenhouse gases that are coming up from this, what was once a carbon sink.
Yeah, absolutely. I mean, it had been a carbon sink for tens of thousands of years. And, we're at this point now where things are changing, and this very ancient fossil carbon is now, at risk of entering into the atmosphere and, contributing to our global climate.
You can see photos of the permafrost thawing that Sue's organization shared with us. Again, the WOODWELL Climate Research Center on our website, wnpr.org/where we live. Sue, how do scientists know when we think about the parts of the permafrost thawing, how do they measure the emissions? So what are the traditional ways? And tell us more about the research you're doing.
Yeah, so I mean, there's a couple different ways you can measure emissions. For the work that I do, I'd say I do it on the ground. And so when you're in tundra and you have short vegetation, you essentially can put a chamber over the ground and collect the gas and watch it change over time. And then you use those measurements and you would sort of use a model to integrate them over time in space. The other way that we are measuring emissions is using eddy covariance towers. And again, this is measuring carbon dioxide uptake by vegetation and also emissions and methane emissions over a larger portion of the landscape. The other ways that people measure it is you can also measure it from, we call this bottom up. So we're measuring it from the ground and then we're sort of extrapolating up to larger areas. You can also measure it from the atmosphere. And in that case, people are measuring concentrations and from that using models to figure out how much is coming out and how much is being taken up. And so we're combining all of these methods. So using on the ground measurements, using satellite data to help us to take these on the ground measurements and to figure out, what does this mean for the Pan-Arctic region? Because as I said, it's a really big region and you're not going to get to every place in the Arctic to be able to measure how much carbon dioxide and methane is being exchanged with the atmosphere.
When we think about these emissions coming from the permafrost, are they built into the international models for the Paris Accord?
Yeah, so this is one of the biggest concerns as far as I see it in terms of carbon emissions from the permafrost. The last IPCC report, the models that went into that did not incorporate permafrost. The models now are incorporating permafrost. Some of them are, but not all. But they generally don't fully account for how permafrost thaws. So the models see permafrost as a top-down gradual process. So the air gets warm and the energy is transferred through the soil and gradually into the permafrost. In reality, though, we have, disturbances such as wildfire that could make that happen rather than millimeters to centimeters per year. It can happen meters per year where you get these very abrupt thawing events. And in cases where you have a lot of ice in the permafrost, again, you can get a ground collapse, which causes very rapid erosion and thawing of the permafrost. So the modeling community is aware of these changes and permafrost is being incorporated into it. But I will say the policy community, this has not been accounted for when we're doing our global carbon accounting, say, for trying to stay below 2 degrees Celsius.
So for listeners here in Connecticut, we may think that this problem of permafrost thawing is so far from us. And can you make the case about why listeners here in our state should care about this?
Yeah, I mean, well, I'd say we should care and we should also recognize that we can do something about it because carbon dioxide and methane are global greenhouse gases. So emissions that come out from the permafrost region affect everyone in the planet because they go into the atmosphere and then they get mixed. At the same time, the actions that we take here to reduce our fossil fuel emissions through, our own personal actions, from actions of our organizations, from our states, and hopefully from the federal government, those also impact carbon emissions from the permafrost region. So we sort of, can take actions on the ground here that will have a global impact.
Well, Sue, I want to thank you for joining Where We Live today to talk about your research and the importance of permafrost and the research finding how much emissions are actually being released because of this thawing. Dr. Sue Natali, again, is Arctic Program Director and scientist at the WOODWELL Climate Research Center, formerly known as the Woods Hole Research Center in Massachusetts. Sue, thank you for your time today.
Thank you so much, Lucy, for having me here.
This is Where We Live on Connecticut Public Radio. I'm Lucy Nalpathanchel. Coming up, woolly mammoths and rhinos, lion cubs, and now an Ice Age bear. They lived tens of thousands of years ago, but some of them have been discovered in Siberia, well preserved in the permafrost. What can scientists learn from them? We'll talk about that after the break. You can join us too, 888-720-9677, or find us on Facebook and Twitter at Where We Live. This is Where We Live on Connecticut Public Radio. I'm Lucy Nalpathanchel. When I was a kid, I was mesmerized when I saw illustrations of woolly mammoths in books. In recent years, researchers have been studying the actual remains of mammoths uncovered in Siberia, like Yuka, a juvenile woolly mammoth.
From its size, it looks as though this mammoth was about 3 or 4 years old when it died. After thousands of years lying frozen in the ground, it's twisted and contorted. Now lying on its back, its head is flopped to one side and its legs stick up in the air. Its foot pads and thick strawberry blonde hair are exquisitely preserved.
That's from a BBC documentary about Yuka in 2012. It was considered one of the best mammoth specimens ever found. There have been other Ice Age animal carcasses found, most recently a well-preserved bear in Russia. Joining us now on Zoom is Dr. Jacqueline Gill, Associate Professor of Paleoecology at the Climate Change Institute at University of Maine. Jacqueline, welcome to our show.
Thank you for having me.
Also with us is Dr. Advait Zucker, vertebrate paleontologist at Yale University. Advait, welcome to our show.
Thank you. It's good to be here.
I wanted to start with Jacqueline. I wanted to ask you about the research trips you've taken. There was a moment, I believe, when you were on the way to see a mammoth foot. Can you describe what that was like?
Yeah, so we were filming a documentary in the Russian Far East, and this vast portion of Siberia that a lot of these really exciting finds have been coming out of. And I had been warned that we would be seeing some really incredible specimens, but I was sort of holding my skepticism. And I climbed up over this hill to see this place where we had been told there was a really well-preserved woolly mammoth carcass. And there were these hoses and people had been kind of clearing the ground. And I was just sort of sitting around waiting, trying to, look around, not really seeing anything too exciting. And then I glanced over and I saw a foot. And it was an elephant foot. It was a woolly mammoth's foot. It was huge. It had skin and toes and, that reddish fur that we associate with these animals. And it hit me like a ton of bricks. I have studied woolly mammoths and their impacts on ecosystems for my entire career, but I really feel like they didn't become real to me until that moment, because I'm so used to seeing them, in my mind's eye or from the clues that they leave behind, and maybe occasionally their bones, but to see the flesh and the fur and realize, this was an individual. This was an individual who felt its last moments, who felt fear, who was aware of its own mortality, stuck in the mud as it approached death. And it was just this moment of realization that it's not just the extinction of a species, but it's these individual stories of these incredible organisms, and that we as scientists have a duty to do right by them and to make their death mean something. And so it was a really powerful moment for me.
It sounds amazing. Advait, you're a paleontologist, again, at Yale University. You study the Pleistocene era. So take us back in time. What would have our state of Connecticut looked like back then?
So the Pleistocene is actually a very long period of time, going from about 2.6 million years all the way up to about 12,000 years ago. And we typically think of the Ice Age when we think of the Pleistocene, but there were actually over 25 different ice ages, where we're most familiar with is the last glacial period, which spanned from about 100,000 years ago all the way up to 12,000 years. At the peak of the glacial period, you had ice sheets that were about a mile thick coming all the way up to New York. If you go into Central Park, you can actually see parts of the rock there which have been scraped over by the glaciers that have left marks on them. What you would have seen south of the ice, so sort of south of Connecticut, would have been a vast plain, which would have been covered with grasses and hedges and shrubs. It's called the Mammoth Steppe.
Mm. So when we hear Jacqueline describe seeing the mammoth foot, when you talk about all of these different ice ages, woolly mammoths were in geologic time really, really recent.
Absolutely. Woolly mammoths first show up on the record about 400,000 years ago, and they go extinct only sometime around 4,000 years ago, so we just missed them. The last refuge for these mammoths were islands off the coast of Siberia and Alaska. And if you think about what's going on 4,000 years ago, people are building pyramids. So there were modern people doing lots of interesting things around the world when we still had mammoths around.
Wow. Jacqueline, you're also an ecologist. So when we think about studying the ecology of the Ice Age, it doesn't exist anymore. But tell us about when you're finding and researching some of these finds in the Arctic and how you're able to do forensics on them.
Yeah, so we literally use some of the same tools that forensic scientists use to reconstruct a crime scene, except instead of tracking a murder, we're actually rebuilding an ecosystem from all of the little bits and pieces that it leaves behind. So the pollen that blows off of the flowers and trees that would have lived in the tundra, some of that pollen settles onto the permafrost or into bogs or lakes, and we can actually take cores of mud, just like an ice core, and remove that pollen from little slices through time, or chunks of plants like a cone from a larch tree or something like that. We also, in our lab, we do a lot of work with dung. The dung that these animals leave behind is some of our best evidence about the kinds of things that those animals were eating. So we can reconstruct not only their diets and a little bit of their ecology, but also some of the landscapes that they lived in, and draw direct connections between the animals that are walking around and the plants that they were walking through. Even the human story can be told from some of these records, as we everything from actual material that people would have left behind, like tools, but also some of the material that is being found in these permafrost deposits shows the signs of what looks like human butchering. So knife marks, or very precise cuts that would indicate that these animals weren't just out there alone; that they were coexisting with probably multiple subspecies of humans through time.
Can you tell us more about how diverse it was back then? We were just talking about woolly mammoths, but what were some other megafauna that were alive at that time?
Absolutely. The Mammoth Steppe was an incredibly diverse ecosystem. It was full of very, very large animals like the woolly mammoths, but of course, you also had animals like bison, Siberian horses. You had woolly rhino out in Eurasia. Of course, you have the bears. You had cave lion, cave hyena. You have wolves. So lots of different species of large animals.
Again, you're hearing Dr. Advait Zucker, a vertebrate paleontologist at Yale University, on Zoom with us, and Dr. Jacqueline Gill, Associate Professor of Paleoecology at the Climate Change Institute at University of Maine. Advait, when we think about studying fossil elephants like mammoths, we're thinking about fossilized bones, but how is the information you're getting from the material that's been uncovered in the permafrost that's been thawing different from what you'd get from bones?
Oh, it's so different. If you go back in time and study a fossil elephant that's a couple of million years old, you're only going to get its fossilized bones. But if you look at these mummies that are coming out of the permafrost, you can actually get flesh. This is something that is unheard of in the deeper time record. You can get a sense of what the biology of this animal was actually like. You can get a sense of what their fur was like, what the distribution of the various tissues were like. And most importantly, you can get DNA out of these specimens. And with this DNA, we can start to understand how these animals are actually related to living species and the various kinds of adaptations they might have had to this very unique environment in the Ice Age.
Advait, do we have any ideas how many of these specimens are likely preserved in the permafrost?
So my colleague Adrian Lister at the Natural History Museum in London once told me that there are probably millions of these carcasses preserved in the permafrost. The permafrost has been forming for a long time, and there were lots of these animals out there just dying and getting preserved. And as the permafrost melts, we're going to start seeing more and more of these mummies coming out.
And Jacqueline, when we think about the information that scientists can get from these preserved animals that have been uncovered, but also what's in their stomachs, what they were eating at that time.
Yeah, so up until really recently, we've been fairly limited in terms of our ability to understand what these animals were eating, or we could understand in very broad terms, grasses, certain kinds of grasses versus more woody material like shrubs or trees. And we have really great data sets about what the plants were like on the landscape. And then, of course, we have this, treasure trove of all of these bones that we use to reconstruct the presence or absence of the large animals. But putting those two pieces together has been really tricky. And very occasionally you can find a mammoth or something else that has its stomach contents preserved, or some dung from one of those animals. And that tells you, very directly that this animal was definitely eating something else. And diet is important for two reasons. One, it's important for us to understand why these animals went extinct. And there's been some discussion and debate about how much of this extinction story is driven by changes in the landscape, so the climate changes, and that changes what plants are available for food. And, a lot of folks have thought that as the available plants have changed, the necessary food for these organisms has disappeared, and that's what drove the extinction. There's another school of thought, and the research that we do in our lab has supported this to an extent, which is that understanding what these animals eat is actually important for understanding their impacts on the landscape. And so, this disappearance of what we call the mammoth steppe may actually have been a consequence of the extinction of these mammoths and woolly rhinos and other animals, rather than the cause. And that has really big implications for how we understand conservation and biodiversity of our largest animals today, which also happen to be some of the most threatened animals on the planet now.
Advait, I wonder if you can expand more on that when we think about these extinctions and the human involvement at the time.
Right. One of the most interesting facts about the megafaunal extinction, which is the extinction of large mammals weighing over 50 kilograms, is that it is a preferential extinction. There's a large size bias. That means that pretty much everything that went extinct was large. And this is something that is unique in the 66 million year history of mammals on the planet. And it turns out that your chances of dying or going extinct when you're large only increases in the later part of the Pleistocene. And it's at this time that humans have left Africa and have spread around the world. This is actually a pretty good indicator that anthropogenic factors like hunting or habitat change had a pretty strong role to play in the extinction of the megafauna. This isn't to say that climate had no role to play. Climate change probably stressed out a lot of these populations, as it normally does. But had people not shown up on the landscape, I don't think we would have seen the same magnitude of extinction that we've seen.
That's interesting. We've been talking about, again, the research and what scientists are uncovering because of these carcasses being found in the permafrost. And Jacqueline, we started the top of the show learning about in places where the permafrost is thawing and the impact. And we may assume that these carcasses are just being found because the permafrost is thawing. But what's actually happening where people are able to find these carcasses? It's not as simple as saying the permafrost is melting.
Yeah, so there's as these finds are coming out in the news more and more, people are often making this linkage to thawing permafrost. And while, of course, that does play a role, and one of the things we should also be concerned about is losing these incredible archives of prehistoric information. But the source of most of these finds is actually people. As the global ivory trade has, there's been a crackdown on the trade of modern ivory because of concerns about elephant conservation. People have actually looked to ancient elephants as a loophole there's still a demand for for ivory that needs to be met. But if you can meet that demand with fossil ivory, it kind of gets around some of these restrictions about the trade for elephant tusks. And a lot of these are going to places like China, and that demand is still there. And so at some point, someone figured out, well, we live in a place with potentially millions of ancient ivory tusks in the ground. And so people have actually started going out in some parts of Siberia and actively looking for these and using a hydromining process, basically blasting the permafrost with river water to create these small tunnels and caves. And as they look for tusks, they're uncovering just tremendous amounts of these mummies, everything from birds to entire bison to cave lion cubs and other things you might have seen in the news. And so it's interesting, but the thawing permafrost has less to do with most of these recent discoveries than just a global demand for ivory and folks sort of finding a way around that.
That sounds really problematic. And then even the idea of tunneling and damaging the permafrost, Jacqueline, for these finds.
Yeah, it's interesting. It's certainly a very conflicting feeling for me as a scientist to both see what's happening on the ground and know where we get these specimens from, how we have access to them. Because on the one hand, we would probably not have most of this information. We wouldn't have found these incredible mummies and all the information that they contain if there weren't these people out in the Siberian wilderness looking for woolly rhino horns and ancient ivory tusks to ship off to the international market through these sort of quasi-legal means. On the other hand, when I've been out in the field and I've talked with the tusk hunters, I don't blame them for using this this way to get their livelihoods, because for a lot of these folks, they live in very rural areas. They don't have a lot of opportunities. They won't get paid unless they find a tusk, and a tusk can feed a family for a year. And so, I don't blame them personally. And some of them are, incredible naturalists. They have really interesting observations about what they find in these tunnels. And, in the grand scheme of things, there are very few people who do this compared to the vastness of the Arctic. So it's probably a negligible contribution to any kind of permafrost collapse. The work is incredibly dangerous, but it's also not very scientific, right? So when I was out there in the field, watching them use a fire hose basically to blast holes in the permafrost, there was so much information that was just being washed into the river. Anything, small-bodied, any potential human artifacts, all of that was just sort of being, flushed away because, the real thing of interest here is the tusks. And so I have this, really conflicting swirl of emotions. Even ancient ivory, some people argue, is still supporting a global demand for ivory generally, and that can imperil elephants. But, I think it's not necessarily cut and dried, right, to be able to say, oh, you're terrible people, you shouldn't be doing this. And, one positive outcome, I guess, if you can say that, is, they do have partnerships with local universities and scientists. And so when something like a perfectly preserved 3-month-old cave lion cub with its claws still sharp and its fur, still intact, and its whiskers and everything still there, when something like that emerges, at least we can capture that information with all of the tools we have at our disposal.
I was also thinking, Jacqueline, these communities, especially these indigenous communities, they are least responsible for climate change, but they are the ones that are most affected by it because of what we heard earlier about their homes having to be rebuilt many times a year because of the shifting, the thawing, the flooding, the fires. It's really problematic for them on the ground.
Absolutely. It's easy for us in the US or many parts of the US to imagine that climate change is something that happens far away to other people. But when I hear from my colleagues and my friends back in Yakutsk, the pictures that they send me of the impacts of the Siberian wildfires, it's apocalyptic, right? So for them, they are feeling the impacts of this, in some of the worst ways. And yet, like you said, they're contributing the least to these problems. And so I think it's important to remember that, the actions, of people well away from the Arctic are absolutely affecting those in the Arctic, just as the Arctic turns around and impacts our day-to-day lives in ways that we may not appreciate. And so I think it's important to remember that these are real world consequences for very real people. You may never meet them, but they know a lot about climate change, and they absolutely understand the ways in which this is a global problem.
Advait, I'm wondering if you could jump in and talk about what Jacqueline has shared, this idea that some of the research material coming from this practice is linked to the international ivory trade.
Absolutely. The international ivory trade has been a problem for a long time. And mammoth ivory coming in has the potential to stop it. But at the same time, there are reports out there which have suggested that people are now masking genuine elephant ivory as mammoth ivory to sell it on the market. So that becomes problematic. However, as Jacqueline said, it's a fairly small scale industry in Siberia, and I'm not sure how much of an impact it's actually going to have on elephant conservation out there.
You're hearing Dr. Advait Zucker, vertebrate paleontologist at Yale University, and Dr. Jacqueline Gill, associate professor of paleoecology and plant ecology at the University of Maine, here on Where We Live. We'll continue talking to them after the break, and you can join us too. Find us on Facebook and Twitter at Where We Live. This is Where We Live on Connecticut Public Radio. I'm Lucy Nalpathanchel. A program note for next week, coming up Tuesday, Connecticut Secretary of the State Denise Merrill joins us for the hour to answer your questions about absentee ballots and even in-person voting if you plan to vote in person November 3rd. That's coming up on Tuesday. Now today we're talking with my guest, Dr. Jacqueline Gill, Associate Professor of Paleoecology at the Climate Change Institute at University of Maine, and Dr. Advait Zucker, a vertebrate paleontologist at Yale University. Jacqueline, again, earlier in this show, we were talking about the impact of the permafrost thawing, the importance of reducing carbon emissions globally to help, but there's some other novel solutions that might help mitigate this damage. There's something called, in Siberia, a project called Pleistocene Park. Can you tell us the idea behind it?
Right. So thinking back to what I was saying about the important ecological role that these animals might have had, there's a thought that having large herbivores in the Arctic helps to make these Arctic ecosystems more resilient to climate change, both in terms of the ways in which herbivores play special keystone roles in shaping and maintaining their ecosystems, just like we would think of an elephant in the African savanna today plays an important role in building the savanna. But also there's some preliminary evidence that suggests that having big animals might help to keep carbon into the permafrost by keeping that permafrost from thawing. So if you imagine, these animals don't get to, hop on a plane to warmer climates in the wintertime. They would have to stay around and make it through that, dark Arctic winter nights. And, the solution there is to brush the snow away to reach the ground and the vegetation below. And so that action of physically brushing and moving the snow away would expose the ground and basically lifts off that kind of blanket of that the snow provides, which actually keeps the ground, having lots of snow on the ground keeps the ground less cold in a lot of ways. And that can be important for lots of other animals too. But in this case, if they're brushing the snow away, they're exposing the ground, it gets colder. It may sort of thicken or deepen that freeze layer in the permafrost, which could then help keep some of that carbon in the ground if that permafrost doesn't thaw as much in the summertime or under warming conditions. And so folks are testing this hypothesis using some of our remaining Ice Age herbivores, things like musk oxen, bison, and horses, and some of these other animals in a place near Chersky in Siberia called Pleistocene Park. And so there's a big fenced-in enclosure. And they, have been releasing more and more animals over the years. I think the bison just showed up last year. And so scientists, including our team, are now studying the effects that these large animals have on the plants that grow in the area. And also, the impacts of those animals on the soil, on the permafrost conditions itself, on the carbon that gets trapped in the ground. And, it's a kind of a moonshot type idea, but it's possible that having big animals in the Arctic, could forestall some of the worst impacts of climate change.
You mentioned a moonshot. Is this idea also controversial?
It's controversial because, like any new idea, we still need to do some groundwork. But it's also controversial because of its ties to the idea of de-extinction, which is bringing back extinct animals using their genetic material that's found in some of these fossils. And folks might have been hearing, for some time now that, within 5 years, we'll have a woolly mammoth cloned. It seems like within 5 years has been going on for about 20 years now. But, at first, the idea was just to do it for its own sake. And now you're starting to hear people say, well, maybe we could do this to reintroduce woolly mammoths into the Arctic as part of some sort of global warming mitigation strategy. This is still a science fiction idea, but the underlining scientific ideas behind it, there's some merit there. So we can, potentially use things like musk oxen or protect the large herbivores that we have now, and help to appreciate the role that they might play in the ecosystem.
Jacqueline mentioned de-extinctionists, Advite. Again, some who are interested in bringing back, as she mentioned, woolly mammoths from extinction by maybe cloning DNA found in preserved samples, Advite?
Yeah, so this idea has been around for a long time, and my opinion may be unpopular, but I'm not a fan of bringing back an extinct species. These animals went extinct a long time ago, and as far as we know, their ecosystem is gone. One of the problems in bringing back a woolly mammoth is that we just don't have all of the genetic material available to bring it back. The second issue is that there are some labs that are trying to take genetic material from a mammoth and then splice it into the genome from an Asian elephant, and then create some kind of a hybrid. Now, this is not going to be a woolly mammoth. It's going to be some kind of a mammophont, if you will. And these animals, which are then born to Asian elephants, are not going to know how to behave like mammoths because they're not. And even if we end up breeding them, we're going to need a lot of these individuals up in the Arctic to actually do the ecosystem engineering that we hope that they would do. And that's just a lot of time and money spent on something that I just don't think is going to have that big of an impact on climate change mitigation. I think it would be a better use of the money if we actually spent it on conservation and conserving the three species of living elephant today, and use other forms of climate change mitigation and adaptation, like actually cutting down on greenhouse gases.
It definitely does sound very sci-fi, Advite, the mammoth font, as you said. Can we talk a little bit more? Earlier, you had mentioned, the last ice age and what we may be able to learn from that Pleistocene extinction when we think about what's happening today with our planet.
It's actually very important for conservation today. So a lot of these big animals went extinct because a lot of them had biological traits that made them more vulnerable. For example, large animals are slow breeders. Large animals need a lot of food. And because of this, and because of these slow reproductive strategies, it takes a long time for the population to get replaced. In times of stress, large animals like elephants and hippos will not breed. What we're seeing in these megafaunal extinctions is that climate change is stressing these populations out. They're fragmenting them and constricting gene flow, which means that these animals aren't interbreeding, and so the genetic stock is deteriorating over time. And then what we've seen is that a small amount of hunting is coming in and wiping them out. So what we're seeing today is climate change occurring at a rate that has not been seen in the past. We already have fragmented populations, and we have habitat change and hunting going on at an unprecedented rate. And basically, whatever we've seen in the Pleistocene is being accelerated now. And if we don't stop it, we're just going to see the extinction of the megabeast to the point where the largest animal on the planet is going to be a cow.
Jacqueline, we just have a couple of minutes left. I wanted to hear your thoughts about lessons that we can take thinking about how to address climate change today.
I think one of the most important lessons for me that comes out of these natural experiments and past climate change is that extinctions have consequences. And when we lose something like an elephant or a rhino from the landscape, we're not just losing really interesting biodiversity that has value for its own sake. We're losing all of the things that animal does in its ecosystem. And especially when we're talking about some of these, what we call ecosystem engineers or foundational species, we're losing a lot of services, including, in some cases, the creation or maintenance of entire ecosystems that other animals really rely on. So anything from moving nutrients around to dispersing seeds to maintaining an open habitat. We see this in places like Africa today. And we thought of, we often think of the Arctic as the Serengeti of the Ice Age. And so if you can imagine, as many or more large animals roaming around in the Arctic just 20,000 years ago as we might see in an African savanna now, you can get some sense of how much we've lost. And so, we have this experiment where losing woolly mammoths, it's too late to save them, but the lessons that they've left behind in the fossil record might help us to, protect elephants, but also the ecosystems that elephants live in now.
It's an important point to end on. Dr. Jacqueline Gill, Associate Professor of Paleoecology at the Climate Change Institute at the University of Maine. Thank you for your time today.
Thanks, it was a pleasure.
And Dr. Advite Zucker, vertebrate paleontologist at Yale University. Advite, a really interesting conversation. You've given us a lot to think about. Thank you.
Thank you so much.
Today's show produced by Carmen Baskoff. Our technical producer is Kat Pastor. You can listen to Where We Live anytime. Just download it on your favorite podcast app. I'm Lucy Nalpathanchel. We hope you have a great weekend.